and also you lose the shared data between everything. And then you have threading. The API for threading is exactly the same. We just call a thread, passing a target. We start the threads, and we join the thread. The difference is we're creating threads instead of process. It means you're creating these executions on the backend, on the operation system. So this is less heavy than creating a process. And also you have the data that is being shared between them. So if you have a global variable, well, these two threads are sharing global variables. If you think about how this works in a pizzeria, it's exactly the example of, this is my order, this is my salami pizza, this is my margarita pizza, and I say, hey, Sean, take this one, hey, Tristan, take this one, and done. But we talk about Python, and Python had something very peculiar. Call it GIL, or Global Interpreter Lock. The Global Interpreter Lock is a mutex, and this means all the threads that runs, they need to get the mutex, the GIL, then they can run. Which means that we don't have much threading or parallelism, real parallelism in Python. Because when the first thread is running, the second one cannot run, because it needs to get the GIL to run. Why this? Well, the idea behind Python, at least since the beginning, was we need to make Python single-threaded faster. And if we need to have sync between all the threads, we need to put more code, we need to put more control. So single thread will be more expensive, and was fine for them to have a multi-thread that is exactly as one thread. And then you have async IO. Async IO changes everything when you talk about the API. It includes two. Async, no way. You use async methods that can wait for something. For example, here is this bake, so we define bake pizza, and we're gonna wait something. So my thread on waiting state, not in a waiting state. And when you call these methods, just call await and the method. This is doing exactly, not exactly because we're not creating threads, but this is almost the same as starting and joining these threads. But again, it's not threads, because what's happening behind the scenes? Well, if you remember the CPU scheduler, that it was the CPU, the OS putting a lot of process and playing around, you have this implemented in a Python level. So Python is responsible to say, I need to run this method, and this method is waiting for something. Or I need to run this method, and this method is ready, and you have this on operation system, on Python level, not operation system level. So this runs as a single thread, and the one controlling everything is called event loop. And I think now we can answer almost all the questions that I bring. So why to run tasks in parallel? Because then you can make things run faster. We can use more resources that you have available. So it's better for the CPU, it's better for the operation system, and also better for the final user. How to run Python tasks in parallel? We discussed three models: multiprocessing, threading, and async IO. And which models to use? I would rephrase this to when to use each model. Well, here we can follow this flow, and it's very straightforward. So, is my process CPU bounded? If the answer is yes, we go multiprocessing. Why? Because for threading, you have the GIL, so works as a single thread. And async IO is single thread. So if you want to run things and using things in parallel for real, we need to use multiprocessing for CPU bounded. If you don't have CPU bounded, so we have IO bounded tasks, we have two questions. How many connections can we open or should we open? If you have just a few, threading is easier because it runs faster than async IO. But async IO, for being implementation in Python, you have less memory being used, so we can handle more connections or more methods running in parallel. Well, and when you discuss this, the GIL itself is something very peculiar to Python. And the community itself is trying to get rid of global interpreter lock for a long time. And if I'm not wrong, this PEP is from last year. So the PEP is the Python Enhancement Proposal. And the idea is making global interpreter lock optional. That means if I'm running something that I know that is single-threaded, I can just allow it there, so it's still running faster. But if I want to use threading, I can use the powers of threading without creating new process. That means start to having threads that are lighter than new process. We had 2 weeks ago, if I'm not wrong, this was merged, the first idea. So if you start playing right now with version, the release candidate for 3.13, if I'm not wrong, you can play. Probably this will break a lot of things, so it's not production ready, because the idea is, let's understand the impact of having this, understand the bottlenecks, understand what needs to be changed. Whew. And that's it. Yeah. We have time for questions. Yes.
Thanks for the presentation. Very nice. And a great example to make it easier to understand. Yes, I said.
So, nice.
First thing, you make things in parallel, and you deliver them as soon as they're ready. So, what happens if you don't use the join or get at the end?
So it's a good question, because if you don't do a join for threading or multiprocessing, this will be finished, but the thread is still running. So you don't have control, and you kind of lose what's being happened there, because maybe a connection will be dropped because the OS has to say, oh, you are something with our parent, so we're going to kill you, but maybe something will be running until it's over. So example, if you open, I don't know, 1,000 connections to send a request to the API and say, oh no, I did something wrong, Control-C. Maybe you're still making all these requests because we didn't have all this control. So when you don't have join, the main program will be finished, but the rest can continue running. Yes, exactly.
Great explanation.
Thank you.
Any other question? Thank you very much for the presentation. You mentioned in the end that I think while being slower than the threading actually requires less memory. Can you clarify that? I think it has something to do with how I think saves the state of the deep connected. So
yes.
Why that quite happen, right?
Yes. So I don't remember exactly the name on the operation system, but you mostly save all these methods when you call. Can you just back here? Yeah. So all these methods, so if I call it 2 times, I'm putting the method still in the memory, but a thread is a new process. So we're still creating a new process, still creating some overhead operation system level. But this overhead is not that big when you have few threads, because you create new, but Python itself, we have the event loop, and the event loop needs to say, hey, now I'm receiving something. So you have a lot of control on top. But once it's on top of Python, async is lighter, even though it's a little more slow. But creating threads, when you have a lot of threads on the operation system, then you start to having operation system overloaded, because the operation system say, okay, I received something. Which one of these 1K threads I need to go? And Python has control because Python created. So it's going against generic, against very specific. And when you have few, threading can be faster. But when you have a lot of connections, then async IO it's better because you don't have the overhead of the operation system. Does this make sense? Okay. There.
You
already
I have one.
Yeah.
So we go to him.
I didn't get exactly what can go wrong with which one. No, I mean, you have limitations, especially if you talk about async IO and you have to, for example, I have a web server using Fast API, for example, that is mostly using async IO, and you need to process a lot of things, then your requests start to getting slower because it's not made for CPU bounded. But doing the slides, I try to force a lot of things. So I forced 100K, 200K, if I'm not wrong. Just this method that start and sleep. For threading took some seconds. For async IO took like 3-4 seconds. So you don't have a real problem unless we start facing things like GIL, then you have single thread. So why my performance is not getting better? And for multiprocessing, it's very expensive. So you cannot even open like 1K without changing the default configuration. So if you need to run 1K things in parallel, multiprocessing can hurt. And then you have all the problems with threading and processing. That is, you have things running and accessing the not multiprocessing for threads. That is, you have things running accessing the same memory. So you need to have implement your own lock. You need to control what is being used, what's being changed. But it's not a bad experience. It's more like understand this concept. You get the bug easier. So yeah.
Okay, you will be, there are more questions.
Yeah.
Yeah.
So when you create a Python thread, that's a slow thread,
Yes.
right? So when you create an IO query, that's like a green thread, like a user thread.
Yes.
So when you create an IO thread, whatever, you have any method and it runs in the method. When you create a system level thread, the operating system sort of has something similar, right? Behind the scenes, it has a loop, of course,
Yes.
floating over the threads, the route robin fashion will be scheduled.
Yes.
So why is it slower when it's Python doing this compared to the operating system?
It's a good question. I don't know if I know how to answer 100%, but Python is not the fastest language for many reasons. And I think mostly it's because of this. Like when you have this operation system is super straightforward and made for this, and Python have some custom code that was written. So it's still having the operation system, and then you have the this event loop on top of the operation system scheduler. So things can go because one on top of each other. But I cannot explain like it's because they use this method or not. This I don't know. Yeah. Yep.
So,
Mhm.
you can.
I realize I'm old. Yeah, thinking like this, but let's see. I come from the era where we had single core CPUs. Now, I go into multi-core CPUs and scheduling. And can you say a few words about that in case we have, would there be anything different considering multi-core CPUs versus single core?
Yes, because when you have more CPUs, yeah, the OS take cares. Unless you want to say, I want to run all my threads in this core, you can do this. But if you just create threads or multiprocessing, the CPU and the operation system take cares for you, so you don't need to. But then it's important to remember, when you talk about Python, we have the global lock interpreter. So maybe it doesn't make a lot of sense using threading, depending on the operation. May make a lot of sense.
Okay, so if there are any more questions, he will be around. So
Yes.
you can ask him. What a fantastic talk, Ariel. Thank you very much. So
Thank you. Thank you very much.
thank you. So we will take a 10-minute break and we'll be back.
The worst way is we have that.
By the way, this
Just close. Okay.
Hello, 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 hello.
Just share one
Yeah, we will share it. Yeah,
and turn it off.
this one is the wrong one, I
The one
think.
we don't need.
1, 2, 3, 4, 5. Good. Okay, cool. I call people back now, man. We should get started. Um, you muted. Welcome back, everybody. So we are now ready for our second talk. It's my pleasure to welcome our very own Eugene Bourdin, software engineer at Tech5 and one of our co-organizers also. So, and he's going to talk to us about architecture in a framework agnostic way for applications with server and also serverless. Well, then let's give a big round of applause to Eugene. You probably should also take the microphone.
Of course, nice. So, hi dear audience. I'm very happy to be here. I'm a bit stressed and nervous because I just broke it stream maybe 20 minutes ago, and hopefully it's not a production infrastructure, so I'm happy. This case. I started my career as Python developer about 6 years ago. I love dogs, love traveling, love sports activities, hiking, cycling, and so on. And now I'm looking for community for my lovely activities. And if someone also like hiking or cycling, I would be happy to join. Or I don't know. We can have a very nice adventure somewhere around. Today I'm going to overview how we can unlock the power of clean architecture approach for server and serverless applications in Python development. I'm going to speak about why clean architecture is useful and important in modern code design. Speak about how we can understand clean architecture, speak about structure, main features, and benefit that it gives to us for development. I will also overview a few code snippets to better understand how we can apply it for our application. And yeah, and snippets focus more, as TBS said, for server and serverless approaches and application as well. So, why is clean architecture approach is important in code design? It gives a few key benefits: maintainability, scalability, portability, and testability. Let's see more in details. What does it mean? What about maintainability? Clean architecture Yeah, all good. Clean architecture enforces clear separation of concerns, make code base more modular and independent. Make it easier to identify, update, maintain different parts of the code base without major changes. Protect us to avoid ripple effects across the system. Because we have layers, we can speak about that a bit later. Helps us to improve maintainability and robustness of our code. What about scalability? Decouple the business logic from it decouples the core business logic from external dependencies. Enable to add that's enabled to add new features or components without major architectural changes. What I said already. Also, easier scaling parts of application by enforcing clear separation of concerns. Portability. It allows us to easy switch between execution platform, frameworks, and external services such as databases, external APIs, storage, etc. It becomes possible because such approach make business logic independent of framework and libraries. If we can say about the stability, it also promotes writing modular and isolated unit tests of components, make possible unit tests and individual parts of the system, because the system it became layered, improve code and test quality, reduce possible amount of bugs, and enhance confidence in making changes to the code base. So let's overview how it looks on the schema. There on the top is entities. It's like highest level. It's the entities encapsulates enterprise-wide business rules. An entity can be an object with methods, or can be sets of data structures or functions. They encapsulate the most general high-level rules. This layer should not be affected when we make some changes on use cases, interactors, or controllers, or frameworks on the layer on use cases, controllers, or frameworks level. So what is use cases? The code in this layer contains application-specific business rules, and it encapsulates and implements all of the use cases of the system. The use cases orchestrate the flow data to and from entities. Possible changes on this layer should not affect entities, as I said about entities. Yeah. We also do not expect that changes on a controller level, on a framework level, or interface level will be affected the use cases. Will be affect use cases. Interface and adapters. Code in this layer is a set of adapters that convert data from the format most convenient to use cases, and entities to format most convenient to external services such as databases or API, etc. Frameworks and drivers. This layer this layers interacts with external services. Excuse me. Yeah. This layer interacts with external system and frameworks, providing a set of tools such as libraries, frameworks, and some technologies for connecting with external world, external system. So if summarize this clean architecture paradigm define how to structure an application to be maintainable with business logic at the core, defines a consistency of application layers, and define dependencies rules and clear boundaries of application layers. So let's see the proposal of structure of a code. We can see the directory entities. It will contain entities. It will contain a core business object and specific business logic for that object. Use cases. The whole use cases. It's like interactors for entities of this application. Repositories will contain abstract interfaces for interacting with external systems. Infrastructure will contain implementation of such repository interfaces. In the controllers will be implementation for external system how to interact with an application. So test will contain tests for such levels and such objects or classes that we such logic that we implemented in like SRC directory. So let's see on entities. It's like a code snippet. It's like just to show how it's just to show more obvious how it works. So as I said, these are the core business object in application. It's encapsulate the main parameters or entity and the main excuse me. So it contains main attribute and methods that contains business logic for such entity. If you talk about use cases, the use case contains applications business logic that contains application specific business logic, like not enterprise, application specific. How the let's say how we can use our application and what it's doing. It orchestrates, how I say, it orchestrates flow from and to entities. So if you say about repository, it's like interface, abstract interfaces, just for definition, what we can abstractions that define external interface for the use cases. It's in an interfaces to allow the use cases to communicate with an external systems. They should be implemented on interface layers, which is like external to the business logic. On infrastructure repository, it's abstractions that implement external interfaces for use cases. It's inherit abstract methods and behavior from abstract repositories, and also should be implemented on interface layer. Interface layer. So for I just just use something like a Flask to show how it's just to better overview how it works. So the controller handle HTTP request, converting data from the request that's coming from UI or from some API user, and direct it to use case. And use case operate with this data and direct this data to entity. And then do some action with what is required. Here's like just register user. It's also implemented on the interface layer. Let's imagine if we have new requirements for our application, and we need to handle not only HTTP requests from API users or UI, and we also need to handle some cloud events. And what we can do here, we can just need to reuse our already implemented repository that connects to the database, and just reuse here use cases, and write a simple wrapper, write a simple handler for the cloud function. And this is it. That's why it can be useful for serverless. And this shows how it's possible to change, how it's possible to easy change framework or execution method if we encapsulate our business, our enterprise-wide business rules to entities, and application business rules into use cases. So, what about unit tests? It also yeah. What about unit tests? Using the separated layers, we can cover each case or each layer independently of others. It allows to separate tests to small unit tests and cover it. It covers all possible cases and makes tests obvious. Also, it's easier to mock external dependencies such as databases, storage, and other external services, because we have small. Excuse me. Because we have small pieces of logic, and we have a layered application. So let's make a conclusion and summarize it. Clean architecture is an approach that helps us to make application more robust, helps to keep code base clean and more maintainable, extendable, and improve readability. Enable possibility to switch between frameworks or code execution methods. Reduce external dependencies. Helps us to unit test our code base. Makes unit tests more independent of frameworks. What I forgot to say. Maybe you can help me with the questions. So, questions, yeah. Oh my God, I love it.
So, question on abstracting away the database. We've done that before, interface, an adapter for it. In practice, it's a bit of a pain, and the promise was that it gives us a bit of freedom if we ever change databases, which we never have, never will, realistically. So it feels like it's an abstraction that has a cost and not a lot of big value for us.
You mean you've been
from having this abstraction?
Do you mean abstraction for the database abstraction, like a database connector or database interface?
Having an abstract interface for the repository and then an implementation of the repository, and trying to keep that separated
The
On the unit test side, the reason
the
to do it was sort of also to have unit tests.
I understand your question. The abstract repository is not necessary. I think so, but it's makes more clear and more makes more consistent code, because if we implement a new new adapter, we have to inherit all methods, what all abstract methods, all interfaces, what we declare in a parent, like for in abstract repository. So if we migrate from example MySQL to Postgres, we need to I don't know. I don't know how to better explain. We need to implement all methods like create user, add user. I don't know, aggregate the average salary of our all users. We need to implement this all interface, and we can't miss it. But it's not necessary, of course. Am I answered your question? Maybe more details?
My experience was that these sort of migrations from one database to another are so rare that
Yeah.
trying to pay for the cost of it up front by introducing the abstraction is actually a type of premature optimization. You're better off doing a Yagami approach. You ain't going to need it. Chances are you're not going to migrate from Postgres to MySQL. And if you will, pay the cost when you will. Otherwise, you're paying the cost on an ongoing basis for something that you want to make the option of doing. That's just been my experience. I'm curious if you've actually had this, like, felt the benefit of, okay, it's nice to have this abstraction for 2 years, we paid the cost of it, and now we have the benefit of it.
No, sure. On my current project, there is also, I can say the example, there is a connector to database, and we have only the adapter, like only the adapter, database adapter that contain like how we create the query, how we execute the query, and how we like operate with the parameter that we put to this query. And there is no this abstract class under this database adapter, and it works. But I don't know, maybe it's good to have like declared interfaces, what exactly we but yeah, also we need to, in the future we need to support it. If we add some new case, we need to support it. And also, yeah, good point. Thanks.
Okay, go ahead. So maybe it's a follow-up question, but I thought that you are really competitive, but there are really big discussions out there about competitive competition. So I just wonder your opinion, which what you think about that. They say the inheritance can be negatively affected by their predicting the composition instead of intelligence.
I prefer more composition, and I think I use all approaches, but inheritance I use only for inherit the interfaces for SQL adapter. But also maybe here I also use it kind of composition, because I just pass the it's like, I'm not sure if it's actually composition, but it's like kind of I just pass the object session to repository, and then repository to user management, and I not declare the how I can need to create the user repository inside of user management use case. So I just, yeah. So I actually it depends on situation, and yeah, usually I prefer composition. What do you prefer?
For interfaces, I think it makes sense to make abstract classes. Other than that, I will use composition.
Thank you for your question. Good point.
Cool. There was another question like over there, right?
I have basically the same question.
You have the same question.
In the same.
Any other question? Okay. Good one. So, have you ever been in a situation where you wanted to migrate an existing web base to clean architecture?
Existing code base to clean architecture. Yes. Yes.
Was your going to erase everything, or
No, just part by part, but it was like more. Okay, I will say how I do step by step. I understand that it's impossible to just manipulate with existing code. So I create the directory core and pour there all what I need step by step. And then like a plan to switch executing flow from current version to core and then remove the previous.
We have another question. Right at the back.
Thank you for the presentation. Very general question. You explained the scenarios where the clean architecture is nice, applicable. Can you give examples of kind of systems that you not develop in this style? Where you think that it might cause more problems than benefits?
I think if we have let me think. I think if we have, for example, small projects, small functions that have to like execute pretty simple logic, we probably don't need it. If we understand in future that our application will grow, and of course we can't imagine all cases how all cases about future. But anyway, if we imagine maybe it's possible to make some basement to start implement this way. But anyway, that's for my opinion is a good way to separate the code by layers and use classes and separate logic from one method to few simple methods. Because it's easy, or I don't know, one huge classes to few simple classes and use composition because it's easier to test it. And also it improves robustness of code and avoid us to make, I don't know, unexpected bugs. Because if we use like, if we split our code to small parts, it's easier to test it. Yeah, as I said, if we cover our code by tested and get like maximum coverage, we can prove that it's like a 70% work. So it's like make more robustness and more give us chance not broke something if we implement new feature or change existing code, because we change especially small part of the system. Yeah. Maybe I didn't understand your question, or
maybe clarification. Like I understand the completely raw idea of building blocks and splitting everything to like a small entity.
yeah.
But here behind also like very specific layers that explain entities, use cases. Then there was the interface problem, yeah, and other like some scenarios where it's hard to attribute those layers. And then therefore, yeah.
Maybe if you can't identify it, maybe it's not necessary. I can say, I don't know. We can speak about this later because it's it's very interesting. It's very interesting question. I think for yeah. Well, let's speak later. Yeah.
So thank you very much, Eugene, for the nice presentation.
Thank you for attention. Yeah.
Yeah.
Can you tell it again one more time I'm joking.
You want another round of applause?
for our watchers.
Yeah.
I'm joking.
I know. So guys, so that wraps up the 2 talks. Thank you very much for coming. Yeah, this meetups wouldn't be possible without you. So yeah, really, thank you. I have some announcements to make. So our last meetup was when, like December, and now we are doing it in March, right? But now we actually have the will to do it every month. If you like, I think go to meetup.com, you will see that we have scheduled meetups every month. So we want to do more events, and that means that we need speakers, right? And I know people sitting in this very audience who have spoken in our meetup before. I'm looking at one right over here. I know there are some on the back. I know that all of you are an expert in something, like the code adventures that you are going through right now. We would be very, very glad if you would share that with us. Yeah. So I mean, if you would like to speak in one of our future events, then please approach either me or Eugene or Daniela over there. Right? Since now I pointed her out, I mean, I should also say that she's one of our new co-organizers, and she's instrumental in setting up this meetup. So a big round of applause for her. Our next meetup is going to be in April. It's already scheduled, April the 18th, I believe, at Zeiss. And we would obviously be like very, very happy to see you there again. So please come. And at the end, I want to, am I missing something? So yeah, that's it. Okay, all right, good. I don't have a good memory. I was just telling Ariel that I don't have a good memory. Anyway, so I want to, at the end, again, thank our speakers, Ariel, Eugene, thank you very much. Giordana, are you here somewhere? I'm here. Yeah, over there. Thank you, Le Wagon, for providing us this space. This was really great. Thank you all for coming. And we can now go back and mingle. What's the time now? 8:35. So at least for an hour, this space is open. So feel free. There's drinks over there. Grab some, mingle, have fun, and see you next time. Thank you. Come again? What?
I would appreciate the reasonable feedback.
Reasonable feedback. So yeah, if you have a feedback for Eugene, please. Yeah.